Picture this: a Russian warship bristling with advanced missiles, preparing to unleash devastation on Ukrainian cities, suddenly finds itself under attack by what appears to be nothing more than sophisticated hobby drones. What happened next would rewrite the rules of modern naval warfare and prove that sometimes the most expensive military technology can be defeated by ingenuity, precision, and parts you can literally buy online. This is the incredible true story of how Ukrainian drone operators, sitting safely hundreds of kilometers away, turned a routine missile launch into a technological David versus Goliath battle that would leave military analysts around the world stunned. The morning sun was just beginning to pierce the horizon over the Sea of Azov when a Russian Buyan-M class corvette took its position in the calm waters. This wasn't just any warship. It was a floating arsenal carrying 8 Kalibr cruise missiles, each capable of devastating entire city blocks. The crew had no idea they were about to become part of military history, nor that their sophisticated vessel would soon be fighting for survival against an enemy they couldn't see, couldn't predict, and barely understood. At exactly 5:30 local time, the corvette's crew was making final preparations for what they assumed would be a routine missile strike against Ukrainian civilian targets. The mission had been proceeding smoothly, with clear skies and calm seas providing perfect conditions for their deadly payload delivery. But unknown to every sailor aboard that ship, 7 Ukrainian drones were already hunting them through the dawn sky, each one piloted by skilled operators who had trained extensively for this exact moment. The lead drone, a modified Rebecca model, suddenly accelerated to over 400 kilometers per hour as Russian checkpoint defenses sprang into action. The distinctive whine of electric motors cut through the morning air, immediately alerting defensive positions that had been strategically placed to protect the naval operations. Anti-aircraft gunners manning 23mm cannons opened fire with deadly precision, sending tracer rounds streaking across the sky like deadly fireworks. Each explosive shell packed enough destructive power to turn these relatively small drones into scattered debris. But what happened next would demonstrate the incredible skill and preparation of the Ukrainian drone operators. The checkpoint gunner faced an impossible challenge. He could hear the approaching drones, but couldn't maintain visual contact in the dim morning light. Relying purely on audio cues, he began walking his rounds toward the source of that distinctive motor whine, a technique that works well against larger, predictable aircraft but proves far less effective against small, maneuverable targets. The lead Rebecca's operator, watching the deadly light show erupting around his aircraft, executed a hard banking maneuver to the left just as 23mm shells exploded mere meters from his position. The drone pushed beyond its normal operational limits, reaching 432 kilometers per hour as it screamed past the defensive position before the gunner could properly track and engage. But the damage to the mission had already been done. The gunfire had alerted every Russian defensive position within a 10-kilometer radius. In our modern interconnected world, news travels faster than military radio communications, and within minutes, telegram messages were spreading warnings throughout the Russian defensive network faster than official military channels could coordinate a response. The element of surprise, so crucial to the mission's success, had vanished in those few seconds of tracer fire. Now the Ukrainian operators would have to rely on skill, technology, and careful planning to navigate an increasingly hostile environment where every Russian position knew they were coming. The lead operator's screen suddenly filled with static as his drone encountered an unexpected obstacle: high-voltage power lines that were virtually invisible until the last possible second. These electrical barriers, carrying 110,000 volts, represented a lethal threat that could instantly destroy the aircraft if contact occurred. The operator pulled back hard on his controls, managing to clear the crackling electrical field by just 2 meters, but the electromagnetic interference wreaked havoc on his drone's delicate electronics. For 3 agonizing seconds, The operator flew completely blind as his compass spun wildly and his video feed flickered between clear images and complete darkness. Every instrument aboard the drone went haywire from the massive electromagnetic field, leaving the pilot to navigate purely on instinct and training. When the systems finally stabilized and the video feed returned, a radio tower emerged from the darkness directly ahead, its guy wires creating an almost invisible web of steel cables that could slice the drone in half. Banking hard to the left with reflexes honed by hundreds of hours of training, the operator missed the deadly guy wires by mere inches. Behind him, two additional Rebecca drones followed the same treacherous path, timing their approach to use the chaos and confusion created by the lead aircraft to slip through the defensive perimeter undetected. These trailing drones had a specific and crucial mission. They were designed to act as the spear tip of the attack, tasked with blinding the ship's sophisticated radar defenses. Without these electronic eyes, the corvette would be vulnerable to the heavier warhead-carrying drones that were approaching from a different vector. The success of the entire operation depended on these smaller, faster aircraft successfully eliminating the ship's ability to detect and track incoming threats. Meanwhile, 4 larger Boomer-class drones had taken a northern approach route, flying at a more conservative 200 kilometers per hour, but carrying significantly heavier warheads. These aircraft represented the hammer that would deliver the killing blow once the Rebeccas had cleared the path and neutralized the ship's defensive systems. The tactical coordination required to synchronize these multiple attack vectors while maintaining operational security represented some of the most sophisticated drone warfare planning ever attempted. But the Russian forces weren't sitting idle while this aerial armada approached their positions. Telegram warnings had already reached the next checkpoint, where a Repellent 1 electronic warfare system waited in ambush. This sophisticated jamming equipment began flooding the control frequencies with 400 watts of electromagnetic noise, creating an invisible storm of interference designed to sever the crucial link between the drone operators and their aircraft. The lead boomer's video screen went completely black as the jamming took effect, displaying the dreaded signal lost message that every drone operator fears. But Ukrainian military planners had anticipated exactly this scenario during their extensive mission preparation. Pre-programmed waypoints immediately activated, and the drone seamlessly switched to autonomous navigation mode, using a combination of accelerometer data and optical landmark recognition to continue toward its target even while flying blind through the electromagnetic storm. This technological sophistication represented years of development and testing, as Ukrainian engineers had learned to adapt commercial drone technology for military applications while working around the limitations imposed by international sanctions and export restrictions. The ability to maintain mission effectiveness, even under heavy electronic attack, had become a crucial capability that separated professional military drones from simple commercial quadcopters. 3 tense minutes passed before the jamming subsided enough for the video feed to return, revealing that the boomer drone was still exactly on course despite flying autonomously through the interference. However, new challenges immediately presented themselves as a BTR-82 armored personnel carrier appeared ahead, blocking the highway with its machine gun already firing in predetermined defensive patterns designed to create zones of deadly crossfire. The drone operator immediately dove into a nearby industrial complex, using the concrete buildings and steel structures to break the line of sight with the armored vehicle's weapon systems. But these same buildings that provided cover from the BTR also sheltered Russian infantry who had been positioned specifically to defend against low-altitude air attacks. The moment they heard the distinctive whine of electric motors overhead, soldiers poured out of their concealed positions like ants from a disturbed hill, each one armed and ready to engage the incoming threat. The operator maintained his aircraft at exactly 10 meters altitude, a height carefully calculated to take advantage of a fundamental principle of physics that most people never consider. The Earth's curvature creates natural radar shadows and a hilltop radar installation that can detect aircraft at 50 kilometers. When they're flying at normal altitude, can only see 12 kilometers when targets are skimming just above the ground level. This phenomenon, known as radar horizon limitation, became the drone's invisible shield as it threaded through corridors of safety that existed only because of the mathematical relationship between the Earth's curvature and electromagnetic wave propagation. The physics of our planet itself was providing protection that no human engineer could have designed. Russian soldiers below fired desperately at sounds and brief glimpses of movement, but they faced the nearly impossible task of hitting small, fast-moving targets that appeared and disappeared behind buildings within seconds. Their weapons were designed for engaging human-sized targets moving at walking or running speed, not aircraft capable of instantly changing direction and speed while maintaining precise navigation through urban terrain. But statistics and probability don't lie, and concentrated fire from a well-coordinated squad will eventually find its target, no matter how evasive the flying object might be. The third Rebecca drone, despite the skill of its operator and the sophistication of its evasive maneuvers, finally succumbed to the inevitable mathematics of sustained defensive fire. The aircraft spiraled into a parking lot where its warhead detonated on impact, sending a pillar of smoke and debris into the morning sky. With 2 Boomer drones and 2 Rebeccas remaining, the Ukrainian operators knew they couldn't afford to lose any more aircraft if they hoped to complete their mission successfully. Every remaining drone represented not just expensive technology, but also the hopes of countless civilians who were depending on this mission to prevent cruise missile strikes against their cities and homes. The lead Rebecca finally crested the final ridge before the target area, and the operator's screen filled with something that fundamentally shouldn't have existed according to their mission briefing. The intelligence reports had been catastrophically wrong about the defensive systems protecting the naval operation. Instead of the relatively light defenses they had expected, a fully operational Pantsir missile system sat waiting, its radar already tracking their approach. In less than 4 seconds, the operator would have to make a split-second decision that would either save the entire mission or result in the destruction of every remaining drone in his formation. There would be no time for consultation, no opportunity to request new orders, and no chance for a second attempt if he chose incorrectly. The Pantsir system launched 6 missiles simultaneously, but these weren't the large, expensive surface-to-air missiles typically used against fighter jets or helicopters. These were specialized Pantsir-M anti-drone interceptors, developed specifically after commercial quadcopters had repeatedly humiliated Russian air defenses in previous encounters throughout the conflict. Each interceptor missile weighed just 12 kilograms, but carried 200 tungsten spheres in a fragmentation warhead specifically engineered to create a donut-shaped destruction pattern optimized for small unmanned aerial vehicles. When detonated, these spheres would expand outward at 1,800 meters per second, creating a lethal cloud 10 meters in diameter, more than sufficient to destroy any drone unlucky enough to be caught within that zone of destruction. The Pantsir operator employed what military tacticians call ladder engagement tactics, launching missiles at staggered altitudes to force incoming aircraft to fly through at least one fragmentation pattern, regardless of their evasive maneuvers. The first missile was programmed to detonate at 50 meters altitude, the second at 30 meters, and the third at 10 meters above ground level, creating a 3-dimensional box of death that should have been impossible to escape. The fire control computer calculated intercept points based on the drone's current trajectory and speed, while each missile's proximity fuse continuously sent out radio pulses, waiting to detect enough metallic content to trigger detonation. This represented some of the most sophisticated anti-aircraft technology available to modern military forces, specifically designed to counter the exact type of threat now approaching the Russian naval operation. But the Rebecca's operator had spent countless hours studying previous Pantsir engagements, analyzing every available piece of footage and intelligence data to understand the system's capabilities and, more importantly, its limitations. He knew that the missiles had a critical vulnerability built into their design, a 1.2-second arming delay after launch, a safety feature intended to prevent the warhead from detonating too close to the launcher and potentially damaging the very system it was meant to protect. At 432 kilometers per hour, the drone could cover 144 meters during those crucial 1.2 seconds of flight time. The moment the operator saw the bright flares of missile launches, he pushed his control stick forward and dove straight toward the Pantsir system itself, using the launcher's own safety protocols as an improvised shield. The missiles streaked overhead, their proximity fuses still locked in safety mode and unable to detonate even as the drone passed within mere meters of their warheads. By the time the safety systems disengaged and the weapons were fully armed, the Rebecca was already below and behind them, having turned the enemy's own defensive measures into protection. The operator leveled out at just 5 meters above the ground and lined up his approach on the Podliot K1 radar system, the critical component providing targeting data to every Russian launcher within 200 kilometers. This single piece of equipment represented the electronic brain of the entire defensive network, and destroying it would blind every missile system in the area. The Pantsir's twin 30mm cannons opened fire, each barrel cycling at 5,000 rounds per minute in a desperate attempt to stop the incoming drone. The gunner employed boxing tactics, creating rectangular zones of concentrated fire where the aircraft should theoretically be forced to fly. But the fire control solution required 1.5 seconds to calculate the proper aim point, another half second for servo motors to adjust the gun position, and then an additional 1.5 seconds for the rounds to travel the 2-kilometer distance to the target. This total lag time of 3.5 seconds represented an eternity in the world of high-speed aerial combat. The drone operator had learned to change course every 2 seconds, ensuring that the defensive computer was always trying to solve an equation based on outdated information. No matter how sophisticated the mathematics or how powerful the processing capability, the system simply couldn't keep up with an unpredictably maneuvering target. The Rebecca punched through the defensive fire and slammed directly into the radar antenna array. The drone's shaped charge warhead detonated on impact, creating what physicists call the Monroe effect, a phenomenon where a carefully designed explosive charge crushes a copper cone under such extreme pressure that solid metal is deformed into a hypersonic jet capable of punching through armor like a needle through paper. At 7,000 meters per second, this jet of molten copper punched through the antenna array, the processing units, the operator stations, and finally the back wall of the entire installation before dispersing into a spray of superheated metal. In less than a millisecond, 200 kilometers of radar coverage simply ceased to exist. The second Rebecca targeted the P-18 spoon rest early warning radar, the backup system that provided overlapping coverage for the naval operation. The Pantsir systems immediately switched to thermal imaging as their primary detection method, but the dawn conditions created a temperature inversion, a layer of cool air trapped beneath warmer air that causes thermal shimmer and false heat signatures as the different temperature layers mix and interact. The drone's electric motors generated minimal heat signature, perhaps 10 degrees above ambient temperature, making them extremely difficult to track against the warming morning sea that still retained heat from the previous day. When flying over cooler land patches, the aircraft actually appeared as cold spots that would disappear entirely from thermal sensors designed to track jet engines operating at 600 degrees Celsius. The thermal imaging system's processing algorithms, optimized for traditional aircraft with hot exhaust signatures, simply couldn't maintain a reliable lock on such small temperature differentials. The Pantsir gunner fired in desperation mode, using predetermined spiral patterns that expanded outward from the drone's last known position. This water hose technique might work against helicopters that cannot change direction instantly, but proved completely ineffective against aircraft capable of pivoting 90 degrees in half a second. 5,000 rounds were expended, with 0 hits, achieved as the second Rebecca struck the P-18 radar system dead center, eliminating another 200 kilometers of radar coverage in an instant. With both primary radar systems destroyed, the corvette 4 kilometers offshore had lost its early warning network completely. Without the Pod Lyotte and P-18 radars providing initial detection and tracking data, the ship's own radar systems could only see 40 kilometers in any direction, giving the crew less than 2 minutes of warning time before incoming threats would arrive. The defensive shield that had been protecting the corvette throughout its mission had suddenly vanished, leaving the ship that had been preparing to launch missiles at Ukrainian cities now blind and alone in increasingly hostile waters. The corvette's radar finally detected the incoming boomer drones at 4 kilometers distance, but these contacts appeared and disappeared with each ocean wave, creating an almost impossible targeting problem. The Russian ship faced the nightmare scenario of trying to distinguish 3-meter altitude drones from 2-meter ocean swells, both of which created radar returns of similar intensity and behavior patterns. The Doppler shift that normally allows radar operators to separate moving targets from stationary objects failed completely when the drones flew at variable speeds between 80 and 120 knots. The computer's clutter rejection algorithm, designed to filter out sea spray and wave returns, began treating the actual threats as false contacts and filtering them out of the display. Every third radar sweep, the drones disappeared entirely from the screen, as the processing system decided they must be electronic noise rather than real targets. This created a deadly game of electronic hide-and-seek, where the ship's most sophisticated sensors were being defeated by the natural environment they were operating in. The AK-630 M2 duet system spun up with a mechanical whine that could be heard across the water as 10,000 rounds per minute erupted from twin 30mm cannons. The fire control computer attempted to calculate future positions using Kalman filtering algorithms, mathematical processes that predict where a moving target will be next by combining its past positions with current sensor data and the laws of physics. But the Ukrainian operators were deliberately throwing off these calculations by making random control inputs every 2 seconds, ensuring that no mathematical model could accurately predict their aircraft's future position. The duet system had been designed to engage large anti-ship missiles weighing 3,000 kilograms and flying predictable ballistic trajectories, not small drones maneuvering randomly through 3-dimensional space. Trying to hit these targets was like attempting to use a sledgehammer to swat a hummingbird. The weapon system was simply too large, too slow, and too predictable to engage such small, agile targets effectively. The computer needed 3.5 seconds to generate each firing solution, but the drones changed course every 2 seconds, meaning the mathematical calculations never had time to align with reality. Undeterred by their complete inability to hit the incoming threats, the corvette deployed its PK-10 decoy system, launching clouds of chaff, aluminum strips cut to exactly half the wavelength of targeting radars. Each metallic strip created a radar return larger than the drone itself, and within seconds, hundreds of false targets bloomed on every radar screen within 50 kilometers. Against radar-guided missiles, this countermeasure would create an impenetrable wall of confusion, making it impossible for incoming weapons to distinguish real targets from decoys. But against drones guided by human operators watching through high-definition cameras, the chaff created nothing more than pretty sparkles reflecting the morning sunlight. The Ukrainian operators completely ignored this light show and maintained visual lock on their target, demonstrating one of the fundamental advantages of human-guided systems over purely electronic warfare: the ability to see through deception that might fool a computer, but appears obvious to trained human eyes. The corvette's TK-25E electronic countermeasure suite activated next, pumping out 200 watts of electromagnetic interference across the entire spectrum from 20 megahertz to 40 gigahertz. Against normal radio-controlled drones, this broad-spectrum jamming would sever the control link instantly, sending the aircraft spinning helplessly into the sea. But the Ukrainian drones employed frequency-hopping spread-spectrum technology, jumping between 128 different communication channels per second in a pseudo-random pattern known only to their operators. The jamming affected individual frequency hops, causing occasional frame drops and pixelation in the video feed, but never blocked enough sequential channels to completely break the communication link. The video quality degraded from high definition to standard definition, annoying for the operators, but still perfectly usable for completing their attack runs. This represented yet another example of how sophisticated military technology could be defeated by clever engineering and adaptive tactics rather than simply overwhelming firepower. Sensing that catastrophe was imminent, the corvette captain ordered emergency evasive maneuvers at maximum speed, but physics doesn't negotiate with human desperation. The 949-ton vessel needed 15 full seconds to change, heading by 30 degrees, while the attacking drones needed 50 milliseconds to completely reverse direction. The Rebecca operator recognized the ship's evasive pattern and timed his final approach for the brief, steady period between turns, when the vessel would be forced to maintain course long enough for a precision strike. At 500 meters range, the operator switched to manual control, abandoning the computer-assisted systems for the precision that only human hands and eyes could provide. The ship's radar mast filled his screen, 6 meters of critical electronics that represented the nervous system of the entire vessel. The duet cannons couldn't depress below -5 degrees elevation, and at 200 meters range with the drone flying at 3 meters altitude. Simple trigonometry put the aircraft below their minimum engagement angle. Sailors with PKM machine guns fired desperately from the deck, but they faced an impossible challenge. The drone crossed their entire field of view in less than 1 second, while human eyes need 0.2 of a second just to focus on a moving target, another 0.3 to track it, and 0.2 more to aim accurately. By the time their nervous systems had processed what they were seeing, the drone had moved 100 meters from where they were aiming. They were literally firing at after images burned into their retinas, chasing ghosts while the real threat streaked past their defenses untouched. The lead boomer drone was aimed directly at the ship's main mast, its shaped charge warhead primed to destroy the communication and radar arrays that allowed the corvette to coordinate with other Russian forces and launch its deadly cargo of cruise missiles. The captain screamed orders for emergency launch procedures, desperately trying to fire the Kalibr missiles before his ship was completely crippled. But the launch sequence required 2 full minutes for gyroscope alignment, target validation, and missile systems warming, a complex process that couldn't be rushed without risking catastrophic failure. The boomer drones were now just 30 seconds away from impact, and there was no technology in the world that could compress those safety procedures into the time available. The first boomer slammed face first into the mast with devastating precision. Instantly, every radar system, communication suite, and data link aboard the ship went completely dark. No longer able to coordinate with shore-based systems or fire their missiles at predetermined targets, the crew found themselves trapped aboard what had suddenly become little more than a floating target. The second boomer dove toward the corvette's port side at a carefully calculated 30-degree angle, its operator aiming for the precise junction between structural frames 44 and 52. Behind this specific section of hull plating lay the missile magazine, protected by just 15 millimeters of steel that would prove utterly inadequate against a properly designed shaped charge warhead. If the attack succeeded, the resulting explosion might detonate the 8 Kalibr cruise missiles stored in their launch cells, potentially turning the entire ship into a massive fireworks display that would be visible for dozens of kilometers in every direction. At 100 meters range, the operator made his final adjustments, accounting for the ship's 8-knot drift rate and 3-degree list from the emergency turn maneuvers. The shaped charge needed to hit at exactly 90 degrees for maximum armor penetration. Too shallow, and the explosive jet would deflect harmlessly off the hull plating. Too steep, and the energy would be wasted in the wrong direction. The operator had practiced this exact scenario 500 times in computer simulations, but reality included variables that no digital environment could perfectly capture. His hands were shaking from adrenaline. Sea spray had fogged his camera lens, and he carried the crushing knowledge that missing this shot meant Ukrainian civilians would continue suffering under Kalibr missile bombardment. The boomer struck exactly at the missile magazine's forward bulkhead, and its shaped charge, a precisely engineered copper cone surrounded by high explosives, created the Monroe effect with devastating efficiency. Detonation waves focused into a jet of superheated metal moving at 7,000 meters per second, and the 15-millimeter steel plate offered about as much resistance as tissue paper against this hypersonic projectile. The molten copper jet punched through the hull and sprayed across stored ammunition and missile components, while the second boomer simultaneously hit the missile handling equipment that connected to the vertical launch tubes. Hydraulic pumps, fuel lines, and electrical systems that transformed inert missiles into precision-guided weapons were instantly destroyed in a cascade of secondary explosions. The explosion ruptured 3 separate critical systems simultaneously. Hydraulic fluid at 3,000 pounds per square inch sprayed across electrical control panels, creating instant electrical fires that spread throughout the ship's interior spaces. Missile coolant lines burst, releasing toxic hydrazine derivatives that forced crew members to evacuate entire sections of the vessel. Most critically, the warhead safety interlocks that prevented accidental detonation were severed, leaving 8 Kalibr cruise missiles armed but completely useless. Deadly weapons that could no longer be controlled or safely disarmed. Despite the catastrophic damage, the corvette managed to remain afloat and limped back to port 12 hours later. The vessel that had departed as a symbol of Russian naval power returned as a smoking, blackened hulk with its superstructure destroyed, its hull breached in multiple locations, and internal fires still burning in compartments that emergency crews couldn't safely access. Recovery operations would require a minimum of 18 months, assuming Russia could somehow source replacement components through the maze of international sanctions that had been steadily tightening around their military-industrial complex. The 8 Kalibr cruise missiles that had been intended for Ukrainian civilian targets remained unfired, their deadly potential neutralized by an operation that had cost a fraction of what those missiles were worth. Ukrainian drone operators, sitting safely in reinforced bunkers 300 kilometers away from the action, had successfully knocked out a warship worth $500 million using components that could be purchased on commercial websites like Alibaba. This engagement would be studied in military academies around the world as a perfect example of how asymmetric warfare, innovative tactics, and human ingenuity could overcome seemingly overwhelming technological advantages. The age of traditional naval supremacy was ending, and the future belonged to those who could adapt fastest to a world where the most devastating weapons might be assembled in a garage and operated by someone who had never set foot aboard a military vessel.